Welcome Year 12s to this next chapter, which is looking at the financial solver, which is a really handy tool in this topic, and you're going to find you're going to be using it extensively from now onwards. So we have used a recurrence relation so far to model reducing balance loans. We've also used an amortization table, but this is a really speedy way of doing all the calculations, I guess, that we would be required to do should we analyse one of these loans. And the financial solver will allow us to do this more efficiently. And the reason we want to do that is because when you are looking at something like a home loan, you might be looking at potentially 25 or 30 years worth of payments. So in those respects, an amortization table would just be far too tedious. You'd have pages upon pages worth of payments to calculate. And a recurrence relation is no good either because, again, we'd have to just find every single amount owing for every single compounding period in the lead up to the one that we want. So if we wanted, say, 10 years down the track and it was a monthly payment, we're looking at 120 compound periods in that time. So financial solver is going to make it more efficient for us. To find it, you're going to click on menu and then number 8 for finance and number 1 finance solver. So I'll be doing that throughout this video. So menu 8.1, that looks like this when it comes up. Now, just to note that the easiest way to move between each of the entries is to just press tab, which is over here above control. You'll find that's the easiest way to move because some of these, if you say want to enter in 12 and then you press the down arrow, it starts to change the value. So if I want to put in 12 in that particular entry, pressing tab is the best way to move to the others without changing that value. I wanted to touch on that first because we're going to get straight into it. In terms of the finance solver, I've put a list there of what we could use it for. But you'll see that's pretty obvious once we get to all these other things we'll investigate in this chapter. Now, what we do with the finance solver is we enter all the variables that we know. So, for example, for N is representative of number of payments in the calculation. If we know that, we'll enter how many payments there are, how many compounding periods there are, straight into that cell. And then we'll press tab to move to the next one. The next one represents the interest rate. Now, really importantly, that's always per annum, so we don't need to divide by 4 or by 12 or by 26 at all when we're using the finance solver. It will do that for us. So that's obviously going to make things easier for us. It's going to eliminate that step. PV represents the present value of a loan. So I also like to think of this as the starting point. The reason I like to use starting point is sometimes we're not talking about the principle of the loan. We're going to look at some examples where you actually change something partway through a loan. And so I will refer to this as the start. And then this one down here, FV, as our end point. So we call that future value. So say we wanted 10 years down the track, the value in 10 years would be solving for the future value. Now, if you have a situation where something's being paid off, so something is being repaid altogether, you make your future value equal to 0. That means that there's nothing left owing on a loan. PPY means payments per year. So how many payments are being made in a 1-year period? If it is monthly, you'll have 12. If it's quarterly, you'll have 4. If it's fortnightly, you'll have 26. You get my drift. CPY is almost the same. In fact, when you enter these two will pretty much always be the same value, that is. But CPY represents the number of times it's compounded in the year. So it doesn't mean exactly the same thing, but the numbers that you put in there will pretty much be the same no matter what example you come across. I've never seen them different in this course. The one at the bottom is just whether the compounding is happening at the start or end. Just leave that as end. We won't need to change that one. It's just the others that are going to be changed. One other important note is that whenever you enter values into your finance solver, some of those values might need to be put in as a negative. So the ones that might be negative, PV, PMT, and FV. Those three there might be negative. Now, the reason this happens is that I mentioned before we can use the finance solver for all of these things here. So for loans, for interest-only loans, for annuities, we will get to them later, for perpetuities, and we can also use them for investments where you add to the principal. So what this means is the calculator needs to know whether it's money that's going to the bank or whether it's money coming from the bank. And because we can use the solver for all these different scenarios, the calculator won't know unless you tell it which way the money is being transacted. So if we have a look at to the bank means it's coming away from you or away from the customer. And so if you imagine your own bank account, some of you will be using a bank account now, when you are paying money, that might come up as a negative on your bank statement. So it means money is coming out of your account and it's going to, say, a shop or to the bank if you're paying the bank back for a loan. So away from the customer means it needs to be listed as a negative. And I say often to the bank. The opposite is true. If it's going to the customer, that means it's being deposited in their account, which means it should come up as a positive in their account. It's really important that whenever you're entering into the solver that you pause and you think about the positives and negatives, because this is one of the key points where errors are made. I've put a couple of little descriptions there about when it will be positive and negative, but I will touch on it as we go through these examples anyway. I've got 5 to look at with you, 5 what I call basic ones, and then in the next video, in a follow-up video, I'll do the more complicated ones. So here we've got Matt borrowing some money, so borrowing $3,500 for a motorbike, and here's our interest rate, 6.3%. Over here it says adjusted monthly, meaning that it compounds monthly. So we've got a lot of information just in that one sentence that can go straight into the solver. Notice in the notes here I've got a table. This table is to show what we're entering into the solver, and that's effectively your workings. So if you come across a question in the SAC where you're using the solver, it is imperative that you show exactly what you've shown, or what you've entered rather, into the solver. What would be Matt's monthly repayment? How much is Matt going to pay back? Now, I didn't touch on that before, actually. I think I skipped over it by accident. This one, PMT, is the amount of a repayment that's either being paid or received, because when we look at some things later, a payment can be received. In this case, it's a loan, so he is paying that money. He's giving that money up, and we actually want to know what that is. So I'm going to put a question mark next to PMT. I'm putting a question mark because I don't know what that is. I can't enter that into the solver. That's actually what I'm going to find. Okay, so what's the monthly repayment if it's fully repaid in 2 years? What I'm going to do to start off with is work out how many payments would that be. So what is N? Since it's monthly and it's 2 years, that's 2 times 12, so I've got 24 payments. The rate was 6.3, that was given in the question up here. And PV, that's the amount that he's borrowed, so that's the initial value of that loan, the present value of that loan. Now that's going to go in as a positive because that money there is given to Matt to buy that motorbike. So since it's coming to him, it needs to be positive. In 2 years, it's fully repaid, which means that the future value has to be 0. There's nothing owing at that point. It's a monthly payment and it's compounding monthly. So the bottom 2 values we put into the solver are 12 and 12. What I'm going to do is show you how to actually get a result come up for PMT. It's really straightforward once you see it once. So I won't show you all of these examples in the calculator each time. But notice I've entered the first 3. I'm going to skip over payment because I don't know it. Future value is just 0, which was already there. PPY is 12 and CPY is 12, so I'll leave them as is as well. I'll just keep pressing tab to get back to payment. This is what I want. To solve for this one, all I have to do is press enter, and you'll see that is the payment that Matt must pay to have it fully repaid in those 2 years. I will need to round this off to 2 decimal places. It's at 595, which makes it 0.60. So in my solver, this is what came up. Notice it's negative. All that means is Matt is paying that money to the bank. He's not receiving the money. He's giving it to the bank. What's really important is you don't leave that value there on the left as your final answer. You must show your final answer separately to what's over here so that you are demonstrating that you're interpreting this is what Matt must pay, 155, not negative 155. The negative is only there to tell us which way the money's going. Secondly, what would the total interest be that's charged here? Well, we know that if Matt pays back all of that money, so the 2 years worth of payments at 105.60, we get the cost of the loan if we do that calculation. We want to know though what's the difference between that cost and what he borrowed initially. Remember, he only borrowed $3,500. So 24 payments is what he's giving up. 24 payments of 105.60. So there's that bit there, that's our cost, and we're taking away the principal. When you do that calculation, we should get 234.40. And so that's the extra amount that Matt has had to pay in order to pay back the interest on that loan. We'll do a similar thing with the next question. We've got Mark and Tamara. They've taken out a loan, $23,000 for their wedding. They're going to pay it back over 7 years, and here's our rate, 6.5% per annum, and it's debited monthly. So remember, that means compounds monthly. Let's get that info into the calculator. We've got 7 years and it's monthly, so 7 times 12. Now what you can do is that in your calculator. When you press tab, it'll come up automatically. And not to worry about anything that's already in here, because you can just override it like so. Oops, that did not work. There we go. So if you put 7 by 12, the reason I find it easier is sometimes you're working with like 15 years and it's monthly or it's fortnightly, so you're doing 15 times 26. Instead of doing that in a separate calculator screen, you can do it in this one right here. So I just wanted to show you that. If I was doing this question right now, I just override anything that was in there, so you don't have to delete the whole thing to start off with, and then you will just go to your payment and press enter. I'll show you what I just did though. I did 7 by 12, it came up with 84. I've got 6.5%. The initial value of that loan's 23,000 positive because it came to Mark and Tamara. They're paying off the loan in those 84 payments, so that's going to be 0. 12 payments a year compounding monthly. We'll press enter up here, so I'll just put equals, that's where I've got my answer. 341, it's got 537 ... I like to put that there so that when I put my rounded answer down here, at least if I've rounded incorrectly, I've shown that I have actually got the correct answer. It was just a rounding error instead of an actual entry error. I'm just going to fix that 3. So this is their payment monthly to pay off that loan in 7 years. We're asked again about interest. How much interest will they pay altogether? So in terms of the cost of the loan, they have to pay $341.54, and they're doing that for 7 years with monthly payments, or in other words, times by 84. So you can do it either way. When we calculate that, we get $28,689.36. So our interest, we need to do cost of loan, or cost, I wrote cost loan there, minus the principal. Now we know 28,689.36 is what they have spent altogether on that loan. They only borrowed 23,000. So as a result, we get 5,689.36. So you can see that their wedding has cost them an extra $5,689.36 because they weren't able to pay for it fully. They had to borrow all of that money, and they've paid it off over a substantial period as well, so over 7 years at quite a high rate of 6.5%. So it's a more costly way of them paying for that wedding. However, they were able to pay for it straight up and then pay it back gradually with this small payment here monthly. Okay, you'll see this one, number 3, is in 2 parts. So we'll have a look at why that is the case. Terry's repaying $52,000. I'm going to put that straight into PV. It's doing that over 15 years quarterly, so 15 by 4, giving us 60. With quarterly installments at 6.25%, so there's our 6.25, adjusted quarterly, so compounding quarterly. Remember, quarterly compounds means a quarterly payment as well. Now, it's saying currently 5.5 years have passed since the loan was drawn down. Now, when it says the loan was drawn down, it just means it's 5.5 years since the loan was started, so since it was borrowed. How much does he still owe? Now the thing is, the reason there are 2 tables here is you'll notice in this paragraph, not once are we told how much Terry is paying per quarter. We don't know what the payment is. We're asked how much does Terry still owe, so we're actually being asked for the future value. But we can't get the future value until we know what goes here in payment. So what we can do, since we know that it's a 15-year loan, we can put 0 for future value. It's going to be repaid after 60 payments, and solve for PMT. Now when we do that, we get negative 1341.765, and I'm just going to put ... because that keeps going. Once you've done that, leave it in there because now that's going to be in my next calculation. I needed it for this calculation. Just leave it in there unrounded. And I want to know future value. So after 5.5 years, what is owing? So it's still PPY, CPY 4. The original amount that was borrowed is still the same as well, as is the rate. What's changing here is the number of payments. So 5.5 years quarterly. So 5 fours are 20 and half of 4 is 2. So we've got 22 payments for 5.5 years. Once we do that, we'll go down to tab down to FV and we'll see what's owing on this loan. It comes up as a negative. Now that's expected because the future value basically says if Terry was to end this loan right now, the amount that he would have to pay to the bank right now would be $38,231. So what that means is it's not money going to him, it's money that's owed to the bank, and that's why it comes up as a negative. I'm just going to round that now to 2 decimal places and have it written outside of this table so it's clear this is my final answer. This is what Terry's owing after 5.5 years. So don't be alarmed if that happens. Sometimes you have to find something first and then keep that in the table and then find what is actually being asked of you for the question. Second last one now, Andrew borrowing $20,000 at this rate 7.25. So I'll just get that information in straight away. It's compounding monthly and it's monthly repayment, so we'll put 1212 at the bottom. It says here that there are monthly repayments of $200. So if that's going to the bank, we need to put that in as negative 200. How much does he owe after 3 years? So 3 years monthly, 3 by 12 will give us 36. Now we go down to future value, which is what we're trying to find. We're finding amount owing, so future value of the loan. And that will come up again as negative because he is owing money at this point. That is money that has to go to the bank should he cease the loan right now. And we'll put our final answer underneath, correct to 2 decimal places, so 0.97. So there we have just under 17,000 owing. As you can see, how long will it take to pay out the loan? Answer to the nearest month. So how long will it take for us to get this future value to be 0? A lot of this stuff is going to be exactly the same, so just enter that straight in. Since it's asking us how long to pay it off, we don't actually have an entry in the solver for time. What we do have though is number of payments. So what we can do is find number of payments and then convert that to how long that would be. We've got enough information to solve for n, so we will do that and we get this happening. And so as you can see, it says answer to the nearest month. So it's 153 payments plus one that's a bit smaller. So altogether that would be 154 payments, which is 154 months. In terms of how long that would be in years, well, 154 divided by 12 would give us 12 years, since 12 12s are 144. Since 144 months are accounted for here, that leaves us with 10 months left over to get us to 154. So 12 years and 10 months. Now this last one here is a bit more of a challenge. So determine the total interest after 3 years of repayments. Now you'll recall that normally we can just do cost of loan minus principal when we do interest, when we're trying to find interest. The problem is that's really only applicable when you're talking about the total, like the end of the loan. What we want to do is have a look at the difference between, after 3 years, what has Andrew paid back and what has he paid off the loan? I'll just take this out because this bit's not going to work for us here. It's not going to work because he hasn't paid everything back yet. We want the difference between amount paid back and the amount paid off the loan, which sounds really complicated, but I'll show you what I mean. For the amount paid back, that's the easiest part. So the cost to Andrew so far. Well, he's done 3 years of payments. I'll just go up a little bit. After 3 years, it says here he was still owing, so he hasn't paid it off, as we can see. 3 years of $200 payments. So we're going to do 36 by 200. So we can do that on here. 36 by 200. We get 7,200. So Andrew has paid all of that money back. However, if we look up here, after 3 years, he owes $16,826, where he borrowed $20,000. So notice here that he hasn't even paid back $4,000, less than $4,000 that he's actually paid back. To work out how much, we're looking at the difference between these two values, so difference between what he borrowed and what he owes. So, amount paid off of the loan. So he borrowed $20,000. He owes $16,826.97. Let's do that now. 20,000 minus 16,826.97. And we get 3173.03. So notice this is a bit trickier than interest questions so far. So he has paid back $7,200, but in terms of what he's paid off the loan, only $3,173.03. So his interest must be the difference between these. He has paid this back, but only paid off this amount off the loan. So let's get that now. 7200 minus that answer there. So interest so far has been $4,026.97. So a large amount of interest so far on this $20,000 loan. One last one now. Just here, we're asked how long ago did Petra borrow this money here? So this $14,000, which she's used to buy a car. So in terms of the $14,000, I can get that straight in, positive, because it came to her to begin with when she borrowed it. It's been charged at 9.2% interest, adjusted monthly. And she's been paying a monthly amount as well of $446.50. Don't forget, that's got to be negative because that amount is being paid back to the bank. It says here currently, so after this time period, she's brought the loan down to a balance of $9,753. Now, because it's not yet paid off, that has to go in as a negative because it's still owed to the bank. So once we do that, we see that this is our one thing that we don't know, and that's what we're going to use to get how long ago that Petra borrowed this money. When you put that into your solver, you should get this. So as you can see, we're going to have to round this one off. 12 payments. Since it was monthly, that equates to 12 months, or, of course, that is 1 year ago. She must have borrowed this 1 year ago to bring this loan of $14,000 down to this amount, $9,753, using that payment under this interest rate. As you can see, there's some key things to remember, of course, and that is mainly the positives and the negatives. You're going to need some practice with this, which is exercise 9C. And in a follow-up video, I will go through some of the more challenging problems with the finance solver, and that's where we have a change to the conditions of the loan.